All right, guys, welcome back. This is the second part of your lecture series for the image processing class. What we're going to walk through is some basic Matlab code, maybe not so basic, where you're going to use some image processing, and with that processed image, you're going to use some computer vision to make some smart, intelligent decisions and get some information out of the image series or the video series that you're looking at, right? And all of this code that I'm basically providing you at this point, that's also part of uh, the video series, will be helpful for your homework. So make sure to listen in. And if you have any questions, again, feel free to reach out to Dr. Consos or reach out to me at MDM359. That's Mike Delta Mike 359 at drexel.edu. All right. So with that, I'm going to share my screen. Hopefully you guys have all the Matlab code that's required to be running this tutorial session. But if not, definitely ask Dr. Consoles as well. All right. So what I first want you to do is open this file called blob detection, which is basically what I have opened up right here. And essentially what we are trying to do is to get information from an image or a sequence of images, which is basically a video, and detect blobs. Over here, we're going to try and detect green blobs and essentially count them as the video progresses, right? For that, first thing I'm going to do is use my Matlab code. I'm going to clear everything, close everything, and then I'm going to load some of my data set. So I can basically select all of this and press the button F9, which runs all of it. The pause button expects you to actually press another key. So as it says over here, pause to press another key. So with that, I am show video frame 1. I have the original image, which is this one right here, right? So with that provided, my next move is to try and threshold this image so I can get only the green blobs. So what I'm going to do, and this is something that you guys will need within your Matlab as well, is you need to install the app that does image processing and computer vision, if you guys don't already have it. So once you have that, I'm going to go to color thresholder, right? And it's going to open up this window right here where I'm going to go to load image and say load image from workspace. Going to get this page and I'm going to say, all right, load video frame 1. Okay. So this is essentially where that color space that we talked about in the lecture kicks in, right? So I'm going to use one of these color spaces to tell apart my image sequence. Now, I'm going to use the HSV, but you guys can feel free to use any of the other ones as well. I'm just using this as an example. You probably want to have a trial and error before you actually do use one, right? So I'm going to use this color thresholding map to remove as much non-green material there is while keeping all the buoys, right? So it looks like I still have quite a bit of the buoys. Nope, I'm losing some. All right, come back. I'm going to select this and I'm going to remove some of the rest. Select that. Okay, I still have the buoys, but yes, I still have some of the tree line that's still over there as well. So I can try and work with some of the saturation to try and remove that or like minimize that, if anything. I don't want you to remove too much of that. And try and play around with the other parameters. Oh, nope, don't want to do that. All right. So once I have this, like this bottom right space also shows me the color space that is left. And with that, I'm going to then go to my export and hit export function, right? The export function is basically going to give me this function value, which if I'm writing a more complicated program, I can always like call for create mask. But essentially, I just need to copy paste this much of this subfunction, right? I'm basically getting the RGB to HSV, and then I'm defining the threshold for channel 1, channel 2, channel 3. And then I'm creating the mask, which then gives me that image. So once I copy paste that, I'm going to stick that. I need to save it because I already have it in my code. I'm going to stick that thresholded image right here, right? So once that is done, I'm going to run this. So I'm pressing all that. I'm hitting F9, and it's pausing, and I'm going to hit pause, and it should have my secondary thresholded image, which obviously you can see over here is provided, and I'm still getting a little bit of a tree line over there too, right? So the next thing for me to do is to remove the disturbances, and this we are going to use by using something called a structure element, which is the strel function over here. Definitely look up structure element and the IAM open function as well, as this will be quite useful for you in your homework. When you select all this, press F9, and this has given me a cleaned up version of the image with the structural element. So I'm going to hit pause again. Then I'm going to run something called the blob analysis, which is a package that you get with the computer vision software. So now that the blob analysis is run, it's basically going to analyze blobs that have a minimum area of 200 pixels or a maximum blob area of 5,000 pixels, and then basically list out the object area, object centroid, and put a box around it, right? So once I have that, then I'm going to annotate the image. So I'm going to press F9 for, and this is going to create another image for me, which is going to give me my identification. And then another one where it provides the analysis of how many boxes are there, and that's going to give me that there's only one box in there, right? So once I have that, essentially then you can release the HBlob analysis parameter, and you can close on. So that was a basic example of how you work out with blob analysis with the given function. Now, if my Matlab will respond at some point, here all, which removes all my CLC, which removes everything from here, right? So now I'm going to run this function called all frames blob, which essentially, if I run, should take that buoy run.avi and do the exact same thing, but for the entire video, right? So while you're doing a live video stream, you can essentially identify how many blobs there are and find out where they are in your picture. So I'm going to hit run over there. It's running, and you guys can see this. So it's counting one blob. So it's one green blob. It's still trying to count two. And then once that keeps on happening, it's going to keep counting on, and then working with it from there on. See, so this basic information that you have, based on the location of these blobs and how much they move, you can tell if your boat is, well, moving to the left or the right as well, right? So that's that computer vision information that you can grab. All right, so that's some of that work. I will also show you some crack detection material if my page opens up again. Right. So this is basically part of the crack1.jpg. Basically running the same thing. I'm turning it into grayscale. I'm putting a Gaussian filter on it, and then I'm binarizing it. And then I'm going to do a black and white area open. From there, get the perimeter, and then calculate the area of the crack. So once that is done, have the crack. And so this is a crack that we're trying to determine what's happening, right? so far it's, I'm show gray is showing up over here. Next, we're going to do a Gaussian filter. Which comes up as that. And then we're going to convert it to black and white, which comes up as that. And then we're going to clean up the image so it comes up as such. Then we're going to do the parameter identification, which is this part right here, right? So it's only drawing the line on the outside edge. And then we're going to do an alternative parameter identification. This is just so we have it in like pixel ratios. And then try and figure out the area of the crack based on this region props. So area of the crack is 3,584 pixels. Parameter of the crack is 2,316.69 pixels. And oh, I guess I closed all the images out here as well. So yeah, so that's basically how you can get that information off of for crack identification as well, right? Now with your homework, I believe we have a heat map. Which if I can pull up right here, you have a heat map and your question paper, or well, basically your homework statement, states so, a warehouse roof is inspected for suspected delamination and damage. A drone is flown overhead with an infrared camera pointed downwards to identify hotspots, which is basically what you're seeing in your image right here. You're required to identify the hotspots, locate, mark them for the asset manager. Using the example shown in class, follow the steps. So you're going to use the color thresholder to identify parts of the heat map image. So basically you need to find these yellow spots, which are the hot zones, and pull that off by using the color thresholder, then use a structural element and clean up the thresholder image. And you're supposed to plot a comparative figure of cleaned up images using different structural element sizes of 1, 5, and 10. And off of those three, you're going to select which one is a better one. Then you're going to use Matlab's vision.blob analysis object cluster to get those blobs, and then use a minimum blob area of 100 and a maximum blob area of 5,000, and mention the number of blobs found in the combined area. Once you have that, use the bounding boxes to identify location of the blobs and put an annotated image, which basically means count the number of blobs that are there in the image while you actually take it. All right, and that is part of your homework for, well, for your class over here, which is fall 2020 actually. So again, like these are all pretty simple, and if you just Google half of these codes, everything is very well explained. Okay. And yeah, essentially you need to pull out these hotspot blobs off of this image, and you can use most, if not all, of the code that I provided in your series today. With that, again, feel free to like ask questions or like hit up Dr. Consoles or myself. And yeah, best luck with your homework. Have a great weekend.